Hi guys, in this tutorial we're going to be looking at a simple LED circuit in Proteus ICs. Okay, and then we're going to look at how to use some instruments to measure voltages across any resistor placed in line with a LED, and also try to see the voltage across an LED. Okay, and then also use some virtual terminals. Okay, so we'll go ahead and start a new project, and like before we have to choose a project name, so we just call it LED, just LED01. So choose a location. I'm saving mine on desktop somewhere here. Okay, then I'm going to use an F3, I think, one F4. I think F3 is better. F3 landscape, that's what I will use. So next, then I don't need a PCB layout, so next, and then no firmware project, next, and finish. Okay, so maybe before I proceed, let me just put a design title and author and the other detail. So design title, I'll just put simple LED, simple LED circuit. There's probably a problem with this spelling, circuit, like that. Document number, I'll call it it's the third, I think. No, it's the second, so I'll just put 02. Revision, not applicable, so I'm the author, so I'll put my name, and okay. So if I click, it should change. I will go ahead and place components. So component mode, or just place, so type LED, and we should be able to see. I will use these animated, active animated, ones that are colored. So use yellow, red, green, blue. Those are 4, right? So we need a generic resistor. So just type res. It should be here. It says device in library, and it should say generic resistor. Since we are not going to use PCB, we are not going to use arrows, so generic is okay. We can alter the values as we want. Then we also need a 9-volt battery. So type battery, not active source and not cell. Let's go with this one, multi-cell. Then we can also add like a switch. It's either a push button, or if we need a push button, just type button, and it's this one, single pole, single throw, that is SPST, single pole, single throw. Take this one. Then at some point we're going to need a switch, the one that latches. So just type switch and look for that one, active, active interactive single pole single throw switch, latch action. So that's enough for our setup. So first we're going to put these LEDs in. Okay, it doesn't matter. Okay, let's just start with a battery. Place a battery here. Then we start with the push button, that is button, put it around there. Then we'll put a resistor in between, put it there. Then we need, we can start placing our LEDs. They will be in pile to each other. Okay, so that's good enough, I suppose. Now what we are going to do next is to, I think I might have gone for an A4 template. This appears to be extremely big. It's too big, this one. Okay, so what I will do is just to bring the components closer. So in any case, I'm going to connect the wires, and then I still need to put a resistor here. I'll just put a resistor here. It's not necessary, neither is this with the action that we are going to do, so neither is this necessary, but we just put it because of what we are going to do next. Might want to measure the voltages, so you can just put it just in case. I'm going to copy this and then paste it. It's not working. I'll copy, then paste. Paste. It's not working. Copy. I'll just paste. Paste. Then paste. You can only use the mouse button to paste. Okay, paste. And here we can paste. Okay, there we have it. So I'll drag this a little bit downwards so that at least they are in line with each other, and yeah, at the same height or distance. So I'll just make this connection. Okay, I think I better select component mode so that I can easily add wires. Okay, so we're almost there. This shouldn't take up a lot of time. Yeah, like that. So I'm going to try to minimize the space for now. I'll reduce the space by just highlighting and then dragging that closer. Then I highlight this side and drag that closer. Then same thing here, because when we are running the simulation, usually we can't zoom in and out as much as we want. So okay, so that is okay. Right, then I'm going to okay, so now I'm going to just run the simulation, and you see what we have. If I run it, I need to push the button for us to see some kind of action or glow, but nothing is happening. Yeah, because first the resistance is too high, so literally no current is flowing. Okay. Yeah, alright, so we are going to change the value of the resistances so that we can be able to get our LEDs to glow. because this is too high, there's no current going through here, and obviously there won't be anything going through the other branches. So first we make sure the model type we are using analog, okay, not digital. So leave it analog, because even the resistors are in analog here. So we're using analog, we are not using digital. Okay. So now we are going to set to, this is a 9 volts, so it's very small. So we need to set, can set at least 5 ohms. So just type 5, and then change this to, we can make it 20, and we make it uniform 20 ohms. 20 ohms should suffice. 20 ohms. 20 ohms. Okay, so now let's try again, running a simulation. Click. Yeah, now we are getting our LEDs to glow, and that is exactly what we wanted. Okay. Yeah, so the more you lower the resistance, the better the glow that you have. Okay. They have like a current of, they have a full drive current of 10 milliamp. So whatever we are having must be less than 10 milliamps in that branch. So we are going to use multimeter, an ammeter and voltmeters to measure the current and see, and then we try to adjust the resistance and we see if there's any change in the glow. Okay. So before we do that, let's split the circuit into 1, 2, and 3, into 4 parts. Okay. So what you're going to do is to get rid of the wires. I'll select each wire. Okay, I'll just select the wires that I want to delete. Make sure they are red. I'm just trying to break the connection, then I press delete. Okay, then I'm going to drag this to that side, and I'll drag this to maybe down here. Then I drag this to this side. Okay, so let me just bring this one closer, because during simulation we need to make sure at least we see every bit. Okay, I think that's good enough. So what I'm going to do is to add terminals here. Yeah. So I'll go to terminal mode, choose default. So I'll add a terminal here. The terminal has to close somewhere here. Another one there, another one there, and a terminal there, and another terminal there. Then of course from where the power is coming from. Okay. Yeah, terminals are important in a way that in case you have a very complicated circuit, you can use terminals and then split the circuit into more than one parts. You can also have the circuits on different sheets. Yeah, okay, if this sheet is not big enough. The whole point is you can space out the circuit so that you avoid the use of too many wires. Okay. So now what we're going to do is to connect. Let's just connect from here to here, and then connect here to there, there, and yeah, of course here and there, there, and connect this to that. Okay, so now one other thing left to do is to label the terminals. If we don't label them, nothing is going to happen. So So whichever is positive, we need to label it with a unique string or something. So let's just call this plus VE. So that's for positive. So I'll just copy this string and paste it into all these other terminals that I want to be positive, so that I want to be connected to the positive. So that's what I'm going to do for everything. Positive, and this one too is positive. So I'm going to do the same thing for the negative. Just minus and VE. Oh, I need to copy the string. Then I'll paste negative, sorry. Then negative here. Then I also paste a negative here. Okay. Yeah. So that is it. I need to be able to see the push button. Maybe I should just move this close enough. I should move these close to each other so that because they can visually fit into that window, so I have to move it close to just move this one closer. They have a small screen, so also we can try to yeah, I think this is okay. Yeah, this is okay, probably, because I need to have space for the push button. Okay, that's good enough. So if I run it, and you see they're glowing, so they're glowing, right? Yeah. So now what we are going to do is to add a voltmeter and a multimeter, sorry, an ammeter. So I'll put an ammeter there, and I'll do, well, the currents in these branches are going to be the same since we have identical resistance. So we can choose to measure the current in one of them. Okay? So we can okay, maybe we use the other one. We can just adjust this one and create space for so we create space for an ammeter, get rid of that wire. So now we go to the instrument section and choose DC voltmeter goes here, and we need maybe a voltmeter across. Obviously the voltage is going to be the same here, since this voltage here will be the same as this voltage here, the same as that, and also the same as this one. So we only need to measure voltage here as long as the resistances are the same. So we add an ammeter. Oh, it should be DC ammeter. We put it here and put another one here. Then we need to change the orientation to make sure okay, so we change this orientation to make it face upwards. So make sure the positive is connected to the positive side and the negative to the negative. Same thing with the voltmeter, positive to positive, negative to the other side. Okay, so let's go ahead and finish with this wiring. Yeah, it shouldn't take too much time, at least a couple of minutes is okay. Connect this one to that one. Then we should connect this here, and okay, maybe we need to see the voltage there, and we probably need another voltmeter to see the voltage across the 20 ohms resistance. Okay, in case we vary the resistance, then we should see the voltage across. Okay, so DC voltage, we add, I need to choose instrument mode, then let's just add it there. Okay, it's not happening. Okay, let us get rid of this wire. I don't know why it's behaving like that, but yeah, this is so strange. I'll try to move it here. I'm getting the same kind of error. I don't know why. I'll get rid of that and do it again. Let me try to put it here. So I don't know why this wire is doing that, but okay, we just get voltage across that. So if we run the simulation and we press the button, we are getting something, but maybe we should switch to a latch. So delete this and add a latch instead, a latching switch. So a latching switch, yes, that one should suffice. So if I play and okay, so we are getting these amps 0.63 and 3.16 volts here. So if we add up the voltages, we should be able to get the actual voltage, okay, the 9 volt. So we can try to do that and see if we end up with the same. So this is 3.16, 3.16, add, so the one across one across the diode is showing 2 point, so that is 2.67, and we need to multiply that by, we actually don't need to, so now we need the one across the 20 ohm resistor, which is a 3.16 again. So plus 3.16. Oh, that is not right. 3.16. So we are getting a 8.99, which is about 9. Okay. So we've gotten the voltage across this and across this and across that. Should give us 9 volts. Okay. let me check. Yeah, well, not quite, because we still have to cater for we still have to cater for these ones because they're in pair with this branch. Okay, yeah, but the voltage here should be the voltage across this branch if it were in pair. Okay, so if we are able to do the math and do all that, we should be able to end up with a 9 volts, but there's no time for that. Okay, but for the current we should get 0.63 if we add 0.16 times 1, 2, 3, 4, should be able to get the current. Okay, 0.16 times 4 gives us about 0.63, okay, which is 0.64. Okay, so we can alter the resistance, but okay, we can just do it for just one branch. Obviously there will be changes in other branches, but at this point they won't be unique. Sorry, they won't be the same. They will be different. So we can set this to 5 ohms. If we run the simulation again, now we see we have changes. Okay. At this point, the voltage across this is the same as the voltage across the resistance at 20 ohm. So every 20 ohm resistor will have this much. Okay. And now the only difference is here. So obviously, we can add a multimeter and see. Sorry, a voltmeter and see the voltage across this LED. Yeah. So I can switch on and off. Okay. We can go ahead and print this circuit. We'll go to File, Print Design. Orientation is landscape. Fit to page. And okay. So the name should be LED. This one. And okay. Yeah, that will be saved. So look for where that file is. It should be desktop. So somewhere here should have LED something, LED 01. And yeah, we printed in black and white monochrome, so this is what you have. You can choose to print it in color. Okay. Yeah, so if I zoom in, this is our circuit. Okay, with the terminals. Okay. Alright, so that's it for this tutorial.